Shri Gurubhyo Namaha, children. Welcome to our online teaching academy, Ekalaiva. Today we are going to continue with 12th standard physics, ray optics. Today we are going to learn about spherical mirrors. So what are spherical mirrors? Now spherical surface. Now before we go on to spherical mirrors, let us see what is a spherical surface is about. Now look at this diagram, children. Now a spherical surface is a part cut from a hollow sphere. Now this is a hollow sphere and this is the spherical part of it. Okay, so now this surface which is cut from a hollow sphere is nothing but you call it as a spherical surface. Now usually whenever we talk about spherical mirrors, now they are usually constructed using glass and the surface of the glass is silvered. As I already told you, silvered surface have a better reflecting surface. So one surface of the glass is silvered. Now the other surface, through the other surface of the glass, the phenomenon of reflection takes place. Okay. So as far as spherical mirrors are concerned, there are two types of spherical mirrors. One is convex mirror. The other one is called as concave mirror. Okay. So here, now consider this part. Okay. So this spherical surface. Now if the polished surface of the mirror is convex, now if the polished surface is convex, then you call this as convex mirrors. Now in convex mirrors, the outer surface is reflective. Now here this is the spherical surface. If the polished surface is concave, then you call it as concave mirror. Now look at this. This is a concave mirror. Now here the polished surface is outside and inside surface is reflective. So there are two types of spherical mirrors. One is concave, the other one is convex. Okay, so let us go deep into these type of spherical mirrors and let us understand some of the terminologies. Okay, with respect to these type of spherical mirrors, we need to know about certain terms regarding spherical mirrors. Okay, so to start with, let us start with what is called as center of curvature. So what is center of curvature? Okay, center of curvature is nothing but the center of the sphere. The center of the sphere of which the mirror is a part. Okay, so the mirror is a part is called as center of curvature. Now look at this diagram. Now this is the center of curvature. Suppose when you consider this as a concave mirror, there lies this is the center of curvature of the mirror. Okay. The second one is radius of curvature. So what is radius of curvature? Now the radius of the sphere, the radius of the sphere of which the mirror is a part. The mirror is a part is called as radius of curvature. Now center of curvature, it is represented as capital C. Radius of curvature is represented as capital R. Okay. Next we are moving on to the third term, which is called as pole. So what is pole? Pole is nothing but the middle point. The middle point on the spherical surface, the middle point on the spherical surface of the mirror is nothing but you call it as pole, and this is represented as capital P. Okay, so suppose when you consider this to be a concave mirror, the center part of the mirror is nothing but you call it as pole. Middle point or the center part is nothing but you call it as pole. Okay. Now next one is principal axis, a very important term, principal axis. So what is principal axis? Now look at this diagram. Now this is a concave mirror, this is a convex mirror. Now this is the pole, this is the center of curvature. Imagine and just imagine this to be a sphere. Now this will be the center part and this will be the pole. Okay, so the line, now the center line, look at this line. Now this line, it joins the pole and the center of curvature. Okay ma, the line that is joining the pole and the center of curvature of the mirror is nothing but you call it as principal axis of the mirror. Okay, right? Now as far as this convex mirror is concerned, this line is nothing but you call it as center of curvature. The line joining the pole and the center of curvature is nothing but you call it as principal axis. So what is principal axis? The line joining the pole and the center of curvature is nothing but you call it as principal axis of the mirror. Okay. Now whenever a light ray traveling along the principal axis, now look at this diagram. Now here a light ray is concerned. Okay, a light ray passing along the principal axis. Okay. Now after reflection, it travels back along the same principal axis. Now look at the direction of light. Imagine a light ray along the principal axis. So light ray, it goes all the way, incident at P, it gets reflected back. Now when it comes back, it travels along the same principal axis. Okay, and this is also called as optic axis. Principal axis, otherwise also called as optic axis. Okay ma, right. Now the next term is once again a very important term which is called as focus. Focus or focal point. Focal point, otherwise it is also called as principal focus. Okay, to understand this, now let us consider some light rays that are parallel to the principal axis. Now look at these light rays. Now I am going to consider two rays above the principal axis and two rays below the principal axis. Okay, so these light rays that are parallel to the principal axis, they are incident at various points on the mirror. Now this is a concave mirror, children. Now parallel rays that are, parallel rays to the principal axis, they incident at this point. Now let me name this point as A, B, C and D. Now at this point of incidence, they are incident and they reflect immediately. As soon as a ray is incident on the mirror, it gets reflected. So this ray, it gets reflected back in this direction. Now the second ray, it is incident at this point B, it is reflected. The third ray, it is incident at this point C and it is getting reflected. And this fourth ray, it is incident at point D, it gets reflected. So all the reflected rays, they meet at a point after reflection from the spherical mirror. Now this point F, as far as a concave mirror is concerned, this point is nothing but you call it as principal focus, or otherwise it is also called as focus. Okay, now here again I have taken a convex mirror. again I'm considering two rays parallel to the principal axis. They get incident at this point A and B, and they get reflected. Okay, when they rays are extended, they appear to come from this point F as far as convex mirror is concerned. Now here the light is diverged here. Okay, so in the case of concave mirror, the light rays are converged. In the case of convex mirror, it is appearing to be diverged. Okay, so this point where the light rays converge, or this point where the light rays appear to diverge from, this point is nothing but you call it as principal focus, or otherwise it is also called as focal point. Okay, are you able to understand the definition, children? So light rays traveling parallel and close to the principal axis when incident on a spherical mirror converge at a point for concave mirror or appear to diverge from a point for convex mirror. So this point is nothing but you call it as focus or focal point of the mirror. So I cannot write the whole definition here. So I have explained you with respect to this diagram, children. Okay, ma? Right. The next term what we are going to learn is focal length. So what is focal length? Again, let us go back to the diagram. Now the distance, now this is principal focus. Hope you are very clear about this. Now the distance between the pole and the focus. So this distance is nothing but you call it as focal length of the mirror. So focal length is nothing but the distance between the pole P and the focus F is nothing but you call it as focal length. Okay, and this is represented as small f, focal length F, small f. Look at this diagram. Now this is the focal length. Okay, is it clear? And the last term is focal plane. So what is this focal plane? Now focal plane is nothing but the plane through the focus. The plane through the focus, and this plane will be perpendicular to the principal axis. Perpendicular to the principal axis is called as focal plane of the mirror. Now this is principal focus, right? Imagine a plane here. Consider a plane here. I cannot show it now. Imagine a plane here. Now this plane, okay, now this plane is perpendicular to the principal axis. Okay, so this plane is nothing but you call it as focal plane, which is passing through the focus and perpendicular to the principal axis. Okay, so this is nothing but focal plane. So these are some of the terms which you should remember while studying the image formation of spherical mirrors, whether it is concave mirror or convex mirror. Okay, ma, is it clear? Now next we are moving on to a very small topic which is nothing but para-axial and marginal rays. So what are these para-axial and marginal rays? Now the para-axial, now this is the principal axis, right? Now we are all familiar with these terms. This is center of curvature, this is the principal focus, and this is pole. Okay, now what are para-axial rays? Now para-axial rays are the rays which travel, very close to the principal axis, very close to the principal axis, and make smaller angles with it, and make small angles with it. is nothing but you call it as para-axial. Now this rays will be very close to the principal axis. Now they make very small angles with the principal axis. So this is about para-axial rays. And the next is marginal rays. So what are these marginal rays? Now the marginal rays are the rays which travel far away from the principal axis, and make large angles with it. Okay, so they are very far from the principal axis and also from the pole. They make larger angles. Usually, whenever we take rays related to the spherical mirrors, we restrict ourselves to only para-axial rays. But for you to know about marginal rays, we define what are marginal rays also. But as far as our studies are concerned, we restrict strictly to para-axial rays. Okay, so because the angle made by these para-axial rays are very, very smaller, so we can have very good approximations based on para-axial rays with rather than marginal rays. So this is about para-axial and marginal rays, children. Okay, hope we are very clear with the concept. See you in the next video, children. To receive our online lessons, please subscribe the subscribe button and you will be receiving our latest updates. Thank you, children.